All right. What is up, intermediate algebra? D. Smith coming to you from the house. Just spent a day in the city with my wife, Lauren. Took the train in, ended up walking 7 miles, had some delicious Puerto Rican food for lunch, went to this bookstore, hung out, perfect weather, got a little sunburn on the back of the neck, got me a Diet Coke here, and I am ready to rock and roll with some math. This video is going to be short, about 13 minutes long, and the goal of this video is for me to give you all my knowledge on solving equations, how to do it better, some tips and some tricks, some methods that I use, some methods that I think could really be helpful for you, and then ultimately some methods that I want us to use tomorrow when we practice in class. Because see, this homework assignment is to watch the video. Your job is to just pay attention and ultimately write down 3 things that you learned from this video that you think will be helpful. And then also a question or two, so that when we come in class Tuesday, we can get after it and we can get better. That's the whole goal of this class, every class really, but I just want it to be a place of growth. So for the next 10 minutes or so of me solving these problems, jot down a couple things that you learned, and then jot down a couple of questions that you still have and bring them with you to class tomorrow. So, solving multi-step equations. I go full screen snip so that I can write on the screen. So, it's a multi-step because look, okay, let's just talk about what an equation looks like. Let's use this one will be better. I want one with variables on both sides. Oh well, we'll just start with number 1. Notice we've got what's on the left over here. Okay, we have an equal sign, and then we have the 4 over here. Okay, so 2 different things happening. An equation is like a scale. So our job is we need to adjust the scale, move things around on either side of the equation, ultimately to try to find out what n equals, right? That's when it says solve an equation, you're looking for the variable. So our job is to, 1, get the variables on one side of the equation. Doesn't matter if it's the left or the right. I often go left, but it's okay. Get the variable on one side of the equation, simplify or combine like terms, and then use inverse operations to solve. Now trust me, these are going to get a lot harder. So don't jump ahead. Don't think I can do this one, so I'm going to skip ahead. We're talking principles here that you can use for every equation. Okay. Before we start number 1, I just want to remind you what inverse operations are. Okay, inverse operations are when, if I need to move something to the other side of an equation. Let's say, I don't need to do this, but let's say I wanted to move this negative 2n over here. Okay, well the way you have to do that, moving something from one side of an equation to another, is you have to kind of undo the operation. If this is a minus 2n, then I would need to add 2n to get that to go away, to get that to cancel. And then what you do to one side of the scale, you have to also do to the other. So I would add 2n over here. So my new equation would be 4n equals 4 plus 2n. I literally took my original problem and I took this negative 2n that's on the left side of the equal sign, I moved it to the right where it became a positive. I would never do that because now I have an n term over here and an n term over here, which is kind of counterproductive. But you get the idea of what an inverse operation is. Inverse operations undo one another. So if I had x plus 2 equals 5, I would need to subtract 2 from both sides to move that over. But if I had x times 2, what inverse operation would we use to undo that one? Well, we would have to, that's multiplication. That's 2 times x. So multiply, what's the inverse of multiply? Divide. We'd have to divide to undo that operation. And what you do to one side, you have to also do to the other side. So we need to keep two things in balance for when we're solving these. We need to use inverse operations to move things and to get things to cancel out. But we also have to balance the scale as we do it. What you do to one side, you have to do to the other. So let's solve a couple of these equations. I'm going to always draw the line down from the equals because that just shows me kind of, it separates the left side of the scale and the right side of the scale. So get variables on one side of the equation. Both variables are there. They're both on the left, so we're good. Simplify. Well, 4n minus 2n, I can simplify that. Those are like terms. That's going to become 2n equals 4. And now I am ready to use inverse operations to solve. 2 multiplied by n, I need to divide to get that to cancel. N equals. But if I divide on the left, I got to also divide on the right. 4 divided by 2 is 2. Okay? Let's use our principles to solve this one below it. I'm looking. Let's draw our line. Boom. Draw our line. My computer's about to die. That's going to be bad. So we're switching locations so that it doesn't die. Sorry about that, gang. Oops. Actually, we don't have to switch locations, but we got to plug in. All right, you just saw me scramble. Got a little tour of my apartment, but we're back and running. That deserves a swig of Diet Coke. All right, we're looking, and I see x terms are both on the right side, and then there's a number. There's a number on the left and a number on the right. So I think the best thing to do, if we're trying to get all the variables on one side, let's just keep the variables on the right side. Let's just move this. Let's move this 3 to the other side. So how would we move a plus 3? How are we going to undo that operation? You probably thought it. We're going to hit it with a minus 3. And that's going to cancel that out. Minus 3 over here, though. What we do to one side, we have to do to the other. 3 minus 3 is 0. And then we have an x. That canceled. Minus a 5x. Aha! X's are all on one side. Now we are going to combine like terms. X minus 5x. Let's see. Well, remember, that's a 1 in front of that. That's 1x minus 5x. So that's 1 minus 5. That's negative 4. But it doesn't even matter because check this out. Remember, this is negative 4 times a number. Variables are just representative of, it could be any number. So go ahead and think. Let's try to do some in our head. Let's solve this in our head. Negative 4 multiplied by what would give us 0? If you said 0, you are correct. The answer is 0. Let's go ahead and prove that using algebra. We're going to divide by negative 4 to get that to cancel. But what we do to one side, we got to do to the other. And 0 divided by anything is 0. So x equals 0. Nice. Okay, so we're going to practice more of these later. I will just show you this before then I switch to part 2, which is going to be cool. If you ever see parentheses, let's add this. Hey, yeah, I'm making a video. Be quiet. That was my cat, sorry. If you ever see parentheses, then you need to deal with those first. What do I mean by deal with them? Let's take what's on the outside of the parentheses and let's multiply it by both. It's called the distributive property. You've heard of that before. Just refreshing your memory here. So we need to get rid of parentheses first. So negative 3 times 4r is negative 12r. And negative 3 times a negative 8 is a positive 24. This then becomes our new equation, and we solve it just like we did the previous two. Find our variables, draw our line down from the equal sign, move stuff over using inverse operations, and you can solve that one. Okay, how much time I got? 2 minutes. Okay, perfect. I'm going to show you another cool skill. We can use inverse operations to rearrange formulas like this. Okay, this is the famous formula. It's the formula for the circumference of a circle. Okay, but what if instead of we want it to be C, this is solved right now for C, but they want us to solve it for D. What do you mean solve for D? Well, it just means get D by itself. It wants us to get D by itself. So how would I do that? How would I do that? How would I do that? Well, we got to use our intelligence and know that this right here is pi multiplied by D. So how do I undo multiplication? Division. I'm going to divide this by pi so that it cancels and I just have D left over here. But what I do to one side, I have to do to the other, so I have C divided by pi. That is the same formula, but it's been resolved for D now, for diameter. So the original problem told us that circumference was equal to pi times the diameter, which is true. But now we know that diameter is equal to the circumference divided by pi. These both are true statements. We just rearranged them using our inverse operations. All right, let's do last one. Let's do one like this. Yeah, beautiful, beautiful. This will take us home, and I hope you guys are still watching. They want us to solve this formula here. I'm looking at this one. They want us to solve it for u. There's a lot going on here. I see parentheses. I see a t out there. I see a 2. If we want u by itself, check this out. I'm going to do 3 things. I'm going to move this 2 out of the way. Then I'm going to move this t out of the way. And then I should just be able to subtract the v. And at the very end of 3 steps, I should just have u by itself. So